Hello, wonderful accelerated math class. Guess where I am today? I'll give you a hint. I'm at the happiest place on earth. I bet you're having more fun at school though. Today we're going to learn about the volume of pyramids and cones. You just watched a video on where the formula for the volume of prisms and cones comes from. Basically, 3 pyramids can fit into 1 rectangular prism, and 3 cones can fit into 1 cylinder if they have the same base and the same height. So you should have your flip book out. Open it to this highlighted tab. We're going to write down the formulas, do an example, and then you're going to try some on your own. So the volume for both pyramids and cones is actually the same formula. It's 1/3 of the area of the base times the height of the whole shape. So in this first example, this is a rectangular pyramid where the base is a rectangle. So your uppercase B stands for the area of the base, and in this case it's a rectangle, so just base times height or length times width times the height of the figure. The height is going to be the distance from the base to the point that's directly across from it. It's the same formula for the volume of a cone, except the shape that makes the base of a cone is a circle. So we could still write that the volume of a cone is 1/3 of the area of the base times the height. Or we could actually write, instead of the uppercase B for area of the base, we could write pi r squared, because pi r squared is the area of a circle. And then of course the height is the distance from the base to the point directly across from it. So using those formulas, let's try number 1. Actually, it says number 5. I don't know why. I'm going to zoom in here. And this is a rectangular pyramid, which means my base is a rectangle. And then I can find my height because it's the distance from the base to the point directly across from it. Pyramids and cones always have a point and 1 base. So the formula is 1/3 the area of the base times the height. In this case, the area of the base is 15 times 6 because it's a rectangle, and the height of the whole figure is 4. So in order to do that on your calculator, you're going to multiply 15 times 6 times 4 and then divide it by 3. So we'll do 15 times, oops, you can't see it, 6 times 4, and we get 360. So it's going to be 1/3 of 360. To find 1/3 of something on your calculator, you're just going to do 360 divided by 3, which of course is 120. And remember that units for volume are cubed, so it's going to be centimeters cubed. Okay, I'm going to have you try the next 3 on your own, and we're going to pause the video and check back in with you. But I wanted to give you a little hint. If you look at number 6, it gives you the height of one of the triangles that makes up the side, but it doesn't give you the height of the entire shape. So I'm going to tell you what that height is. You actually could find it using the Pythagorean theorem, something we learned a very long time ago in this class. You could find that this is 8, and this right here is 17, so 8 squared plus 17 squared equals c squared. But I'm going to save you the time and tell you that that is 15 yards. All right, so we're going to pause the video and you're going to try 6 through 8. Okay, welcome back. Let's go ahead and do those problems together and see how you did. So for number 6, we're going to do, for this pyramid, which is a square pyramid, we're going to do 1/3 area of the base times the height for the volume. The area of the base is just 16 times 16, and I gave you the height earlier, which is 15. So in your calculator, you're going to do 16 times 16 times 15, which is 3,840, and then you're going to divide by 3 to get the answer 1,280 yards cubed. Raise your hand if you got it right. Very good, class. I see that Hayron got it right and Allie got it right. Good job, Marielle. Fantastic job. Okay. Now let's look at this problem. This is a triangular pyramid. So the area of the base is a triangle, and our height is going to be 8. So we're still doing a third of the area of the base times the height. The area of the base in this case is a triangle. And the base and height of the triangle, here's the right angle symbol. So the area of the triangle, we can do it separately over here to make it easier, is half of 3 times 11. Because the base and the height of the triangle are 3 and 11. So we're going to have 1/2 3 times 11, and then the base of the whole thing is 8. So I'm going to put into my calculator, oops, this should be a 1/2. Thank you for catching that, Elaine. 3 times 11 times 8 divided by 2. So all of this gives us 132. Then we'll do 1/3 of that, and we get 44 meters cubed. Raise your hand if you got that one right. Good job, Colin. Good job, Andrew. Good job, Mira. Excellent. Okay. For number 8, we have our first cone practice problem. We have a circular base here, so we're going to use the area of a circle for that uppercase B. So 1/3 area of the base times the height. Area of the base, here's the radius right here, it's 10. So we're going to do pi r squared, and then times the height of the whole thing, which is 27. So 1/3, and in my calculator, or even in my head, this is 100, right? 100 times 3.14 is 314, so I can do 314 times 27, and then we'll divide by 3. So 8,478 divided by 3 gives the answer 2,826. Now you have everything you need to know to do your homework. You're only doing one side of that worksheet. I know that never happens, but you're just doing the side with the maze for homework. Good job, guys. Do you want to see my homeroom that I filmed this in front of? Some of them are being awfully noisy.
Yay! That would be me.
Who was the big shusher?
Me! Alexa!
Alexa.